So hi, my name is Andrew. I'm a third year PhD student from the University of South Wales. Today I'll be talking about my research, which is computing geographical access to services, the design and development of an open source multimodal client server solution. So a bit about the background of the project. My research is based around enhancing our understanding of accessibility to sports facilities in Wales. It's pathfunded by Sport Wales, which is an organisation that manages sporting opportunities and aims at improving participation of sport in Wales. Although this work is based around measuring accessibility to sport in Wales, it can be applied to other services. The solution can be applied to most accessibility models, but the model used within the work of this is a multimodal variant of the enhanced two-step flow and catchment area model, which essentially provides a supply to demand ratio. There are several aims for the solution. The first is to keep it open source and use open data. This is to keep the costs low, but also allow for customization without restrictions such as waiting for patch release on proprietary software. The second aim is to implement a multimodal method of measuring accessibility to allow people who travel by alternative modes of transport to be included in the accessibility model. This is likely to, the third is based around user experience. A lot of the assessment that is done by non-GIS specialists, so the interface will need to be designed around users that you, without GIS knowledge and computing backgrounds. And the final aim is to be executed in a web-based environment. Sport Wales works with other sport organisations around Wales, so they're required to access off-site, but it also relieves the users from maintaining and installing data sets on each machine they use over the different sites. There are several technical challenges when reaching for these aims and objectives. It requires the integration of suitable online routing engines that use public transport without subscriptions or fees. The solution is required to, it uses a number of different web languages and technologies that need to work with one another seamlessly, passing the data across to the different components in the solution. It requires the development of user-friendly interfaces that the non-GIS experts can use. So now I'll move on to the actual solution. So here's the web-based open source solution. It's made up of different key components, which I'll go through now. The first component is the routing engine itself. This gathers the details from one point location to another point location, creating times and distances for journeys to be used in the accessibility model. There are a large number of routing engines available, which follow the same pattern of like shortest path algorithms. But public transport information is needed for this particular accessibility model. So we need ones that are capable of producing public transport times and distances. In this particular solution uses TripPlanner. TripPlanner is an open source multimodal trip planner. It uses open data to calculate the journeys with public transport. It retrieves its data from a graph built on OpenStreetMap and GTFS data. It uses a RESTful API that responds with JSON and or XML, so the times and distances are extracted from the response JSON. The second key component in the solution is the Spatial Database. It stores the supply and demand location spatial information. In this study, I use Postgres. It also performs the required spatial analysis using its extension PostGIS. It's the component used to calculate the scores and shift the data around. Before I go on to the next components, I just want to talk about what's being used to connect everything together and then show like a system flow, which is the web server that contains all the HTML documents, the style sheets, and the PHP scripts. Each of the scripts are stored on the web server, and it's used to communicate between the various other components. So in terms of the flow, the first stage of the solution is to generate a OD matrix that is a combination of supply and demand locations. These are for calculating the distances from each point location and then used in the two-step flow encashment model. And it requires an ID, the capacity that you're breaking down the facility into, or the population, and the geometry data for both the supply and demand. It acts as a structure for the data during the processes that follow this one. These scripts are used, or they use a Postgres class, which is responsible for generating the SQL to query the database and return the data. The next step is to generate the distances using the routing engine of your choice. It takes the coordinates from the supply location and the demand locations, and then it constructs a URL string. This URL string is then used to query TripPlanner's RESTful API and get the journey information. The script then takes that information and stores it in the Postgres database. Once all the journeys have been calculated for all combinations of the OD matrix and each mode of transport, the public transport needs to be filtered because it returns more than one journey with like different bus routes and time.
So you've got 3 minutes remaining.
Okay. It's filtered by selecting one of the shortest distance. And then these times and distances then added onto the OD matrix. The distances, and then the final stage within the flow is to generate the accessibility scores themselves. All of these tasks have been controlled by the user via a web interface that the user can access from anywhere with an internet connection. Here's the user interface. It's currently a work in progress as I get feedback from Sport Wales. This is where the user would log in from a browser of their choice. The user would interact with each script on the web server. It reduces the amount of manual input and hides away all like the geometry data and some of the inputs, and it stops the users from typing in their own data and getting it wrong, so the system breaks, sort of thing. But these scores it produces are very helpful in a table, so they need to be visualized on a map while keeping it within a web-based environment. So now we move on to the final key component, which is a web map that they can view the scores on and interact with the data, zoom in and key areas, picking out or areas of interest, sort of thing. So the system's up and running. All the necessary parts are working and interacting with each other seamlessly, with successful integration of the technologies and open source tools such as PostGIS, TripPlanner, Leaflet. It keeps the system low cost and open source, along with being customizable for each sport or other service you apply it to. It provides multimodal accessibility calculations, and it uses a simplistic interface that non-GIS experts can use to hide all the unnecessary input, all while being executed in a fully web-based environment. Future plans involve
1 minute.
Implementing a what-if functionality. So basically, for example of this would be if I clicked on the map, it would then recalculate the accessibility showing potential accessibility. So this will help with planning where their next facilities are or changing their current infrastructure. Another part of the work includes exploring different ways of visualizing or representing the data, or how the users interact with the data on the map in meaningful ways. Thank you.
Did you consider using WFS for the data sharing, where you're using GeoJSON, or WPS for the processing component? That's Jonathan's question.
Yeah, I was considering one, but it was just I'm having the main thing was getting the accessibility results to be displayed. So eventually I will be able to extract it straight from the Postgres database with WFS if needed through the Leaflet API. It is open source. I'm just tidying up the code and commenting, and then eventually it'll be on GitHub.
Great. Just a quick question about the open source, actually. So you mentioned in the paper that there was previous research with proprietary software. So compared to the open source solution, like I often prefer it because it's much more flexible open source software. Did you find any challenges though with using open source over proprietary software?
It was reliability of the GTFS data, where I got it from, and maintaining that data set myself rather than having someone else do it and then pay for the subscription sort of thing.